Hello and welcome to another Sneak Live. I'm one of your hosts, Brian Clark, aka Clarkio, and joining us today is your co-host is Kyle Suero. Hey Kyle,
Hey Brian, how's it going?
it's going well, buddy. It's going well. How are you?
Doing pretty well. Really excited to talk about this vulnerability. I think we were able to do some pretty good analysis of it, find a lot of good information really early, and I think if folks are using anything utilizing this package, they'll be able to really just nip that in the bud really quick. So looking forward to talking more about this.
Yes. So let's introduce the idea to everybody. So we're starting this series maybe once a month or so. We're going to be thinking we're calling it Vuln of the Month. So you're watching it right now, folks. Thank you for tuning in or watching this later. Vuln of the Month is about what, Kyle? What can people expect with this show?
Yeah, so I think it's kind of what it sounds like. Vuln of the month. We're going to talk about a new vulnerability every month. Maybe we'll have there's so many good vulnerabilities. We might change it up and we might actually have them more frequently. So it might not be vuln of the month, but maybe when we're working towards we're going to have a vuln at least every month, right? We're going to have one stream every month. And we'll probably just discuss the most prolific thing that's going on that we can look at in open source and basically in the information security and application security threat landscape.
Nice. So, and the idea is, we'll pick something that's going on. Maybe in this week we got, or this month rather, this episode, we have a vulnerability in an npm package that we're going to take a look at and just kind of learn more about it, understand it better, and see what we can learn from it.
Yeah, exactly. I think that's what we're going to do.
Cool. So, where do we start? What is the vulnerability that we're going to be looking at for this month?
So we're going to be talking about a package called nanoid, and there's a defect with nanoid, and basically the way to resolve this is to update, of course, update to the newest version. But it's an information exposure vulnerability via the value of function, right? So that is basically a function that they're using to generate IDs. They're using, very common core cryptographic components to generate random IDs, right? And these IDs can be used in URLs, right? That's primarily what people are using them for. They're using it for anything from session information, right? Like this is the idea of your session. This is the idea of something you can share with somebody, right? When you generate a link for most services, you get some random ID. So lots of folks are probably using this in one way or another, or through a vendor or something like that. So um, that's obviously something that people want to look out for. And as we know, information exposure is when you're returning something to somebody who shouldn't have that, right? So we talk about confidentiality, integrity, and availability. Obviously, your service has to be available, but the data that you're hosting, has to have integrity. People can't modify it, but also, confidentiality, right? Like you don't want somebody to have your medical data through a provider website or your bank information when you log in through Starbucks, right? So through like the Starbucks Wi-Fi, right? You want to make sure that your data, your critical data, isn't exposed. So information exposure, CWE 200, is a very common defect, and this isn't something that you should worry about and just run around and lose your mind because you do have to be on a box locally, right? You have to be on a network. You have to have some foothold in an environment. So, and then you need to be able to, have that knowledge, right, to modify this value of function, overwrite it, and exfiltrate these IDs, these previously generated IDs. And then you'd need to have intimate knowledge of the inner workings of the service in order to take advantage of that, right? So let's say, for example, you are signing up for a job, and the job you're signing up for uses a common portal. Um, Maybe you're uploading your resume, maybe you're uploading your payment information, right? You've got the job, you're uploading your payment information, you're uploading your resume. These files, they're shared internally so that it gets around to the right folks. Maybe not every person has access to the system directly, but if they're generating IDs and these IDs are weak, perhaps, right? And that ID in the URL is the only thing that is, this is worst case scenario, of course. The ID is the only thing that is keeping somebody from, obtaining somebody else's information, right? Then when you think of it that way, it's trivial, right? If the implementation is, used in that context, right, as an authentication mechanism, so you can share it with folks without an account, so that your team can do all these decisions, right? So if you're using an ID, right, from this as that primary security source, even if you're generating it correctly, even if you have, all the cryptographic parameters aren't, you're not accidentally weakening the key, or the ID that is generated, right? So you're even if you're doing everything right, if somebody's on it has a foothold on the box, right, they can basically exfiltrate previous IDs. So
Oof.
that is the TLDR,
Yeah.
the long
So
one.
that there's a lot to unpack there. I appreciate
Yep.
you going through that. And it does not sound good for one, right? For me coming from a developer background, I'm like, I could see that those use cases coming into play with a library like this Nano ID, but then for that type of vulnerability, oh boy, like that's scary stuff that could happen, right? So let's
Yeah.
talk a little bit about let's take a step back a bit, right? Let's get people acquainted with this package that has the vulnerability in it, and then talk about a little bit more, bringing your expertise of from the security side of things. What's obviously information exposure. The name's pretty self-explanatory, but like going a little high level of like, what does that mean to somebody that's never heard of CWE, which was a term that you mentioned before,
Mhm.
and how does that relate to this? And then we can dive into that. What do you say? Does that sound good?
Definitely, definitely. I think we're in also just let folks know primo what we're going to talk about. We're going to talk about technically what's going on with the JavaScript, like the JavaScript that causes this defect. So you're gonna have a better understanding actually of the actual code that was committed that resulted in this defect, right? And then we're also going to take a look at the fix. So you'll see the actual fix that was applied in order to negate this defect. So I think there's a lot to learn today.
Yes, for sure. And while you were saying that, I was going over to GitHub, and I'm going to share my screen here. Bring it on screen so people can see, to make sure I go to the exact point in time. So that's where the fix came into play. So I wanted to show the code prior to that so we can explore things too with like the version that had the vulnerability in it versus the one that's fixed and what the changes are. So let's take a look at what Nanoid is doing in general. So if I go over here and I look on npm, so if you're searching for something like this, it's a tiny, secure, URL-friendly, unique string ID generated for JavaScript. So the key thing being here, it's unique, right? And we're hoping for that as developers or users of this package, that it's not going to have any kind of collisions, in the sense of it's going to generate a new ID that is the same as something that was previously generated, which is what we're diving into here, right? So let's take a look at how you might use it. You typical in Node application or even front end web application, if you wanted to, you import it from Nanoid after you npm install, and then you just set your ID variable, whatever that may be, that's going to use that unique ID to the end result of calling Nanoid as a module, as a function, and that just spits out, as the example shows here in the comment, some random set of characters that looks like it's 21 characters. I believe the default that they have set is it's 21 characters in length, right, Kyle? Yeah,
Yep. So in the default, I think, yeah, that should be the default configuration.
cool. Um, so really useful, like cool little tool that like pull into your application, having different use cases that Kyle, I know you touched upon a little bit there. So that's what the package does. Let's take a look at like what the code is kind of doing and inside of things. So this is their GitHub repository, and actually I should start sharing these links in the chat for everybody so that they can go check it out on their own if they'd like. Uh, the chat, and then so that people can see that are watching the recording. There's where we're going. npmjs.com package nano ID. So looking at the code over on GitHub, and in particular the state of it before it with the vulnerability in it, is right here. And the main set of code is in index.js, which is not uncommon in Node in the Node ecosystem. So they're using crypto, which is a built-in module within Node.js, to help generate some randomness, right? And again, Kyle, you keep me honest in the terms that I'm using here, because I'm just, regular old developer that has some security, a little bit of security background and knowledge, and a security enthusiast is the way I would probably describe myself. A developer that has security enthusiasm. Um,
You're right on the money, Brian.
all right, cool.
Yeah.
So with that in mind, there's two things to keep in mind to understand that I've come to learn with diving into the code of this, right? there's the module itself that is going to be called here, which is this nanoid. It has a parameter that's expecting that's size, and the default value of that is 21, which is what we are talking about before. It then calls this function called fill pool, which uses that variable that gets or argument that gets passed into it. We'll dive into that in a second. And then after that, it's like, okay, let's initiate an ID variable with just an empty string, and we're going to start filling that ID with values that it's going to create that's unique to give a unique ID. So fairly straightforward. And what it's doing here is it's using a for loop with some comments that's describing how it's filling in and adding to the string. It's concatenating more characters one by one to the string based on this pool thing. Right. And this is the part where I'm still a little bit fuzzy on my understanding of this, but maybe you all will kind of get the gist of it as we step through. So let's take a look at what fill pool means when we pass in the size here. So if I click on that and I go into it, this is the function up here for that. So it takes in that parameter of size, which is used as bytes variable inside the scope of this function. And then it's doing some conditional logic checks. So it's saying, do we have a pool? Has a pool been instantiated, which is the variable set up right here on line 11? If not, or there is one and the length is less than the byte size. So like the default is 21. If the pool length is just 0 or 1 or 2, then it's going to hit this particular condition. So what that's doing is it's then allocating some buffer size, right? And this is the stuff where it's like it's been so long I've been out of practice in terms of dealing with memory and buffers and stuff like that that's where I'm fuzzy on this. But it's basically using some memory space and to help with generating the randomness, and it passes that. So it creates like a set of the way I kind of think of it is like we have a space in memory on the computer, and using that space in memory, we can pass that into the crypto library to fill with randomness, random values, random characters. And that's my understanding of it. So the pool gets filled with that, and the pool offset is 0. The pool offset gets used to pull out character by character from the pool, uh, what to plug into the ID. Okay, so that's what's happening here. That's if the pool's never been created; it's the first time going through. If the pool has been created, then it's just seeing based on the pool offset, where else should it be in creating more randomness to inject using the crypto library. And then it resets the pool offset and so forth. So it's kind of like something that can be called multiple times based on the current state of the pool that's being used to create this randomness. So, and I'm pausing there for a moment to let people to kind of digest that because like I'm even still digesting it myself. But that's kind of what's happening. My understanding of what's happening here with this library. So as a result of that, the one thing that we need to take into consideration here is how JavaScript works. And so what an attacker could do as a result of this, looking at this code that may not be common to the everyday developer, myself included, this was new to me. Not new to me. I've heard of this before, but I didn't when I'm writing code like this, it's not something that's at the top of my mind that I'm keeping into consideration. So when JavaScript does these comparisons like this, like a less than, greater than, or if you use just double equals instead of triple equals, which I don't know if there's any use cases here, or like this one. So this one's using triple equals. And what's helpful with this is it makes sure, it tells JavaScript like, hey, when we're doing this comparison, we want to make sure they're of the same type, and not doing a loose type comparison is the best way I would describe it. Um, so with that in mind, what JavaScript will do in these situations is we're expecting human beings reading this. Length is going to be a number, and bytes should be a number. But what if bytes is not a number? What if bytes is a JavaScript object? What if bytes is an array? What if bytes is something other than what we expect that could potentially happen? And what an attacker or the security researcher found through here is that bytes could be an object. And the way JavaScript works is when it's not of the same type, it will look to the object's function called value of. And oh man, I don't have the link on this machine. It's on my other computer. Darn it. There's an explanation, but if we, Google and search for JavaScript value of, There was, I think maybe it was this one, Geeks for Geeks. No. Whatever. It's fine. But the article, I wanted to give credit to the article because it was super helpful. But what happens is JavaScript when it has to do type coercion. So if we do pass in an object that's into a comparison like that, and Kyle, feel free to interrupt me at any point in time if you have questions that I should elaborate on. Um, when JavaScript is doing this comparison, and this is not of the same type as length, with length is going to be a number, right? It's going to say, okay, well, what's the value of this object that I'm passing in here? Let me use that function to get the value and try and do the comparison there. So that allows an attacker or somebody that's doing something malicious to kind of tap in to that inherent functionality, that behavior of JavaScript, and maybe try to manipulate things in their favor. So this is kind of setting the stage for um, how this attack is possible, or how this vulnerability comes into play. I'm going to pause there as well. Kyle, anything to add or questions, comments that you think we should cover as a result?
No, I think that's it. I think if anyone's confused, I think when they see the Git commit, it'll probably make a little more sense too. So
Yeah.
I think that's an awesome explanation, especially as somebody who isn't particularly a JavaScript guru, but learns a lot from you and our other colleagues, of course. I think it makes great sense to me, so hopefully it makes sense for the rest of folks here, rest
Yes.
of the
And
programmers and developers.
I see Frackberg's in the chat. Good to see you, Frackberg. Thank you for joining us. And shout out to Laron who helped kind of take a look at some of this stuff with me to make sure I was understanding these things correctly too. So, so yeah, that was something that I learned was that if in JavaScript, if the types aren't, especially in a comparison like this where it's like less than, if the types aren't the same, it's going to do type coercion and it's going to use the value of function to execute that type coercion behind the scenes, built into the JavaScript engine, and uh, and then do the comparison that way to see if it is less than or greater than, to see if that condition is met. So, with what Kyle was talking about, let's take a look at the proof of concept that they have here that's going on. So, this is, I'll drop the link in chat as well. This is an explanation of the vulnerability a little bit more in depth, and some details about the vulnerability. It's a medium severity and so forth, but we'll get to that, and I'm going to let Kyle talk more to that kind of stuff. But they have a proof of concept (POC) here to kind of demonstrate what's happening. So when you run nanoid, we're going to focus on the bottom here. Ignore the top so far. You import nanoid and you're going to call it to generate an ID. So it generates ID 1. Then for ID 2, you can actually pass in that parameter. What size of an ID do you want? The default one, like on this one, is 21, but you can control that. So what the researchers found through this is that if we return an object, which we see here on that first line, let me blow it up a little bit so that it's more visible. And that object contains a function that's value of. That gives us access into manipulating the behavior of the program or the code that's going to be leveraging this information, this data. So in this case, they commented it, and I didn't quite understand this at first with the comments, what they were relating to. But if you recall what we were looking at with the source code before, each of these conditions correlate to the conditions in that fill pool function that's helping to figure out what's the character to use at each index of the ID that's going to create based on the size. So value of is the size. So like this value of function that's going to be pulled out through here, passed into nanoid, is telling nanoid what size of an ID we want. And then it's using this step. It's a within the closure, there's this variable called step to kind of help iterate over each ID that it's going to get. And so what it's doing is it's basically tricking these conditions to pass or fail intentionally so that it can go and basically regenerate the previous ID that was generated before. And I think there's a stack blitz somewhere that we can run to kind of see it executing and get the results. Where was that? Do I have it here? Where did it go?
Oh, the POC.
Yeah, the POC. Do you have that link handy?
Yeah, let me pull that up. It's actually here. I'll paste
I
that
go back.
in the chat.
Okay.
Um, remember, it's in the PR. So
Yeah, I just got it. My bad.
oh, there you go. Okay.
Yeah. All right. So here's the stack blitz. I'm gonna drop that in chat as well, so people can see and try it out themselves.
Yeah, and
So
then
stack. Go ahead.
do you think we could maybe explain for folks what type coercion means?
Yeah.
Like
So
in this example.
yeah. So in JavaScript, types are not really like a thing. I mean, there's some primitive types, but it's still very loosely run. I'm not the best at explaining this kind of stuff. I just develop with it and know like have a general understanding of how it works. But so type coercion is basically saying, hey, like let's look at this on line 20, uh this if condition. So it's saying, hey, I have this variable step that we're setting to about, a number type or an integer, and I want to see if it's equal to 2. And so if what will happen is, because JavaScript is, it's a blessing and a curse in disguise, right? JavaScript's super flexible, in that maybe, step isn't actually what you expect it to be. Maybe it ends up being, like I said before, maybe it's another type, like an object. In this case, an object would be, something like curly braces for folks that maybe aren't familiar with JavaScript. And in that case, JavaScript's going to be like, okay, I'm still going to compare these things. I don't care that it's not the same type. I'm going to still compare them. And if they were using just double equals like this, it's going to say, hey, does this thing have a value, and does this thing have a value? Well, okay, it does, and you're going to get different results based on that. The best way I can kind of demonstrate this is if I actually show it in the browser really quick. Let's do that. And if I go, all right, so if I say let step equal string, like low, right? And I say const result equals step, and we want to know if step equals 1. Log out result, we can see that's false. False. So step does not equal 1. But if I say, like const result 2 equals step, and I do triple equals 1, let's say what's result 2, that's also false. This is not a good explanation. I feel like I'm being put on the spot, and now I'm messing up big time, Kyle.
No, no, this makes sense. This totally makes sense. So yeah, basically, because JavaScript doesn't care about the type, it's going to try to use a default function like the value of function in order to evaluate a conditional statement, right? So that totally makes sense. I think um, maybe we can show the POC in the GitHub commit.
Yeah.
That would be
Okay.
cool.
Let's do that. All right. So this is the proof of concept that I had before. Let me get it fixed back up again here. So what this stack blitz, for folks that maybe aren't familiar with this either, it's just like a in-browser editor that you can use and run and execute some code, and it's pretty cool. So I'm going to run node index at the bottom here. It shows you the results of this code right here that's running on line 31, 32, and then it logs it out on line 33. So ID 1 is the first one that gets generated without any parameter passed into it. And then ID 2, you could see it ended up generating the same exact ID. And then, it does a condition to see if those are indeed equal. So that's the problem that's happening here, is that this taking advantage of the way JavaScript works when it comes to comparisons and type coercion, and knowing that it will rely on this value of function, you can use that as a door to break into and manipulate the behavior of the code that's leveraging this particular function.
Definitely. Once
Does
you're
that
able
make sense?
to, yeah, that makes so much sense. So once you're able to, yeah, basically manipulate the underlying right inherited function. Once you're able to control that interaction, right, like the sky's the limit, really, right? Once you're exfiltrating these IDs, all you have to do, and you're already locally on a box, right? You need to have a foothold in order to be able. The reason the severity is pretty low. Oh, pardon me.
No
The
problem.
reason the severity is so low is because, as we've discussed, you need to have a foothold on this box. You need to already have a presence on this machine in order to perform an exploit related to this vulnerability. So this defect isn't that severe, right? It is a local exploit, right? If you are local on a box and you have control of this, you probably have control of a lot of other things that are high value. So the Nano ID devs, they already have a patch for it. And they did a great job. You know, it was responsibly disclosed. They were able to fix this. It's not going to be a huge problem for other packages and other open source projects. Like we saw some React navigation repositories, right, that are utilizing this. Some React core components that are utilizing this. So yeah, it's definitely an important thing for folks to update and to basically I'd say monitor, right, like activity on boxes where there could be something related to this, right? If somebody is going to obtain IDs for a service, right, then maybe they can act on behalf of somebody else and perform actions that otherwise they wouldn't be authorized to do. So it is a attack vector totally, like the randomness of cryptographic schemes, and exploiting that randomness or weakening that randomness has always been a popular method of exploitation, right? Sometimes they're called key shortening attacks,
Oh,
and yeah, so you're limiting the potential range of results you could have, right? Like let's say there is a way to make it, instead of having nano id generate 21 by default, if there's a way to manipulate maybe an install of nano id so that would only generate ids that are like technically like we can only call like 14 characters out of the 21 like random or something like that, because somebody's um you know messing with an initialization vector, an iv, or any sort of nonce, or number used once, right? That's what we
mhm.
call them. So if somebody is manipulating that, or if somebody's manipulating your ids, or if somebody's exfiltrating your ids like this, and they're local on a box, right? Definitely it's devastating, right?
Yeah, yeah. So when like, this is something that I wanna make sure it's clear too for folks. When you mention something, when people are local on a box, like, my mind tends to, as as a human being, they're like they got to the computer physically, and they're locally there, right? And they're able to then, when somebody has physical access to a computer, they might, they have, like, kind of full reign, or, like, a whole, uh, slew of things that they could potentially do with that type of access, right? So when you say local, do you mean that? Or do you mean more of, like, they're somehow they can be anywhere in the world and still get access into the machine that's running the application code?
Good question, right? So yeah, like luckily, right, those attacks where people walk into data centers and are hands on keyboard on your servers, or like you know usually we have stronger methods of authentication for like these physical buildings, and it's all aggregated in one place, or they're managed by service providers, and that security sort of out of sight out of mind. But yeah, I think it's an important distinction to make, that when we talk about a local attack, you already have to have a presence on the box, meaning via SSH or FTP, or like any sort of vulnerability, any sort of service that you can exploit. You need to have already performed some sort of exploit. So when you're gaining a foothold on a box, right? Like you're going to use some sort of thing that will get you like remote code execution, or maybe a reverse shell, right? So that you can interact with the box in different ways, right? Obviously, everybody's critical systems that are doling out IDs aren't necessarily how would you say, like open on the internet, right? For anyone to ping and access, right? Usually they're secured to some degree. So basically, gaining a foothold on that box is the determining factor here as to whether somebody would be able to actually exploit this vulnerability and then exfiltrate IDs.
Gotcha. Alright, thank you for explaining that, and, I think it helps clarify, some of the terminology that tends to be used for folks that maybe aren't as familiar with that, right? Um, so that's super helpful, and thank you for sharing that. Alright, so that's good to know, right? I mean, it's an extra layer of friction in sense of, like, if you are using this nano ID library in your application, it takes that much more. They have to get to that point, and if an attacker's already at that point, you have bigger problems than necessarily them trying to manipulate or leverage nano ID vulnerability, through this situation, right? Would you say?
Definitely, definitely. I think if somebody's already, that's why the severity. So you hit the money on that. You hit the nail on the head, right? So
Okay.
basically, if somebody's already on your box, if somebody is able to overwrite this code, right, on a machine that is actually depending on this package, then yeah, I'd say you have much bigger problems than this. Obviously, patch it, update it, right? patch the service, but they're probably more indicators of compromise and fishy activity, right? If you're noticing that your IDs are no longer secure, somebody's like, oh, like you know this ID was, or maybe there's an ID claiming system. Somebody generates a link. There's a ID, right? And then they go to claim that ID, but somebody's already programmatically done it before them. Like, yeah, there's somebody on your box doing weird things, exfiltrating these IDs, activating them, using them, redeeming them, whatever it may be. Um, and yeah, that's indicative of a much larger problem with
Mm,
the security infrastructure of the supported service, for sure.
cool. Gotcha. I wanted to circle back I don't know if you noticed, I was also trying to do this at the same time, was getting that article I was talking about that helped it I think is super useful to help in understanding the value of function in JavaScript and how that works. So I'm gonna share it on screen. It's in the chat. But then let me also add my screen back up here so that people can see it. And the key thing that I think to call out here that was something that I learned through this, going into this whole thing, and I want to also emphasize that too, is that seeing me struggle with this and kind of understanding it and diving deeper into these types of things, I hope encourages other folks to feel, open to diving into this stuff if you have an interest in this space to get better at it, to skill yourself up, to learn more about it. And like, I am a JavaScript developer, but there are parts of JavaScript that I still feel like my skills aren't as strong as they used to be or strong at all ever. And so this is kind of showing that. So I feel honestly, I'm a little bit stressed because I'm like, oh man, like I'm showing my um the edges of my knowledge in the language, but at the same time, it's good because this forced me to recognize that and to hopefully help other people notice it and realize it that maybe didn't notice it before. So
Definitely, definitely. Well, I totally appreciate you saying that, actually. And before we go on, I actually do want to say, like,
sure,
I didn't look at this and instantly understand everything, understand the PR and like all of that. And I think we, just so everyone else knows, what we actually did for this and what we're probably going to do for the future ones is we come together. We find something that we think is interesting. I'll bring it to Brian and I'll be like, hey Brian, like, what do you think about this, right? And then we'll sort of talk about it. We get in a little session. We just like figure out, is this something we want to present on, right? And then we try to find like the best information for y'all, right, about how to avoid it, right, how to detect it, right, like we're talking about now, and why it happened, right, how they fixed it. So if you're a developer, right, and you're generating IDs, or like when we talk about maybe like some Jenkins stuff, right, like you're working on developer pipelines, like we're going to be covering whatever we can to help you, right, and we're learning about it and then sharing it with you. So yeah, this is a learning exercise for us, just as much as it hopefully is for you. So we definitely want to mold this in the image of like the content you want to see. So if there's anything, any feedback, definitely, we're accessible. So
nice. I think that perfectly captures the essence of what we're going for with Vuln of the Month as a show. And so hopefully you all watching this, you that interests you and you like that and you tune in for future ones as well. But we're not done yet. So let me talk really quickly about this in particular. So again, shout out to the folks at this website masteringjs.io. And in it in particular, what I want to highlight is this is where they talk about it. JavaScript uses the value of function for type coercion when comparing values using just the double equals operator as opposed to the triple equals operator. Okay. So when it's triple equals, that's when it's more strict about the type comparison. Whereas when you use double equals in JavaScript, it's more loosey goosey. you know, so it's kind of like that's how it treats it. And what I'd learned though through this that I didn't realize is it also treats the less than comparison, greater than comparison, less than equal to, greater than equal to comparisons loosey goosey as well in terms of the types, which I should have known that. I probably did know that, maybe I forgot, but I'm no, like reality is I probably didn't. Um, so that's a big thing to take note of, and I think actually this proves and shows, right? This is a library, and this is not knocking the maintainers and creators of this Nano ID library, but the point I'm trying to make here is these are folks. There's lots of you can see lots of contributors to this project. There's also lots of people that depend upon this project that may or may not have reviewed it. I imagine it's a certain percentage of them probably reviewed it, and to get an idea of the depth of that, there are if I go back a page here, according to NPM registry, there's 3,622 packages or projects that depend upon this
Some
package in
notable ones
particular.
too, definitely.
Right, and that's what we were showing here, right? Some notable ones like Mocha. Mocha's
Mocha, yep.
a testing framework for Node.js, Post CSS, and we could go down the list and see there's quite some small ones that maybe are a little bit more niche, but then there's also bigger ones that are widely used that are using this Nano ID library, and the maintainers of those projects may or may not look into this. But you get what I'm saying? Like this is something that could be easily overlooked by even the best programmers in the JavaScript ecosystem.
Definitely,
Uh,
and I think one more little tidbit there about just the dependence, right? Mocha has about like 6 million weekly downloads, right? So it really
Oof.
could happen to anybody. Yeah, and that's the npm module stats from the npm website. So yeah, it's definitely a huge project, and folks, it has 8,800 dependents on npm. So just to give you an idea of how that like branches out and like really affects the open source ecosystem. A package like this, right? Maybe a lot of people haven't heard of it. I know I hadn't until recently. So maybe a lot of people just haven't heard of it, and it's in a lot of the stuff that we're using, though, right? So I think it's something to take note of, definitely, and to make sure that if you are using open source software, you're aware of the vulnerabilities that you're sending out with different version numbers, because that's hard to keep track of as an ex security AppSec engineer, security maintainer, right? Like that was extremely hard to keep track of.
I bet, man. It's
Yeah. Oh
there's so many things that depend upon each other and intertwined in all the programming ecosystems that yeah, it's very overwhelming just thinking about it.
yeah, most definitely.
So yeah, this is so again, shout out to that masteringJS.io describing that the value of function gets used here. So and then the example that they have is they create this class, right? So instead of it being an object, they have a class that they pass in that they're comparing against that they assign to it's ironically a variable named object, and then they compare the object class to number types in JavaScript. And so you can see the differences here of what's going on. When it uses the value of, it's returning 0 for value of there. That's how you tap into that. And it's saying, so is 0 less than or equal to -1? False, right, and so forth. So hopefully that helps clarify a little bit. I'm glad I was able to find the article again and share that because that's really what helped it click for me of what's being leveraged here or what's making this vulnerability possible is when this comparison's happening, this is the input that comes in. And if this is an object that has a function that is not the intended type of an integer or number, then it's going to lean on the value of function. And then that is that foothold into manipulating the behavior of this, how this might result, this if condition, this if condition, and so forth.
Definitely. What do you think? Should we get into the commit, the fix commit?
Yeah, let's do that. Let me go back here. So that was the code before it got fixed. And then if we go into the PR of when it was fixed, we look at the files changed, and we could see they also one thing. Shout out to the folks that are maintainers, contributors to this project. They comment very well around everything, so you can kind of get a better understanding of how the inner workings work of Nano ID. So here, what they did was they changed from fill pool to just bytes and leaving bytes as is.
Oh, Brian,
There.
I
Oh,
don't
I'm
think
not
it's
sharing
ready.
my screen. Silly me. All right, so we're in the PR. This is the PR that happened 16 days ago, and I look at files changed on GitHub, and here's what I was talking about. So before it was fill pool, and it was just taken in the bytes as is, whatever was passed in there. Instead, now you can see they're using this minus equals to convert bytes to a number to prevent the value of abuse that was called out to them. So that's one area they did it, and then they also did it right here, and then that's the extent of what they did to fix it. And then they added a test to help keep the coverage of that with the proof of concept that we talked about before.
That's awesome. So another thing to point out is Nano ID is actually backed by an open source consultancy. So I think that's a really cool thing to see, for the open source ecosystem, right? Folks who, are depending on this technology, right? Folks who, maybe aren't going to write or implement it themselves, or they were going to, they look it up and they see that it exists. I think, it saves us so much time just, as somebody who's a full stack developer. I think open source definitely saves us a lot of time. And to be aware of what you're shipping out and the vulnerabilities associated with it, right? If you're using software with this version, and maybe you don't know, maybe you have manifests and you don't know if you're actually using software with this defect. You can always dump your open source packages into Sneak Advisor, and you can actually see if you have vulnerabilities that way. So definitely, a great free tool for provided by us at Sneak. And also, you could really just sign up for Sneak and use the free SCA to detect this. Like, you could integrate it with your GitHub projects and basically run Sneak SCA on all of your manifests and immediately find out if you have this and then update.
For sure. Yes, absolutely. And point out some of the things that you mentioned throughout Sneak Advisor, here's the link to that for folks to check out. But I'll also share my screen so you can see this is what Advisor pulls up when you search for Nano ID, and you want to see how that's looking in terms of overall health score and security and that kind of stuff. So, in addition to that, one thing I noticed, Kyle, really quick, I know this is a
Mhm.
bit off the beat of what we're planning, but you see the banner at the top now?
Yeah, yeah, that's awesome. I'm so glad we got that up. I think that is really cool. It looks awesome.
Well done. So for
Should we tell people about that? Do you want to tell folks about the big fix?
I do. Perfect setup there. So,
Yeah.
the Big Fix, folks, if you didn't know, is an event that's going on right now that you can join in on, and you can get a unique Sneak T-shirt. So if you like swag, think of it as like a hackathon, and if you complete the hackathon, you get some swag. Who doesn't want some swag? I always want some swag. I can appreciate some good swag. So the idea behind the Big Fix is you find security vulnerabilities and fix them in your projects, open source projects, your team's projects, whatever it may be, to help make security that much better for the year 2022. And as a result of that, you for free, right? It's all free, and as a result of that, you can get a T-shirt. That
I've
sounds nice,
heard.
doesn't it?
Yeah, definitely. You know what makes it sound even nicer? I've heard the t-shirts are incredibly soft. That's what I've been told. Little through the grapevine, little tidbit there. But
Wow.
I think this is awesome, Brian. Like, we're looking at Nano ID, right? We see that
Yep.
it's a key ecosystem project, right? Like, all this information here. Like, shout out to the advisor team, because like this is something that I personally think is super important, right? You can see the health of a package. So if you're going to include this, and maybe you look up Nano ID and you see there's a vulnerability, right? But you can see this is a key ecosystem project here. You can see it's a healthy project. And in the newest version, there are actually no known security issues, right? We saw how they patched it. They patched it effectively. Somebody reported it. And, it was basically a great response. So, shout out to the team, round of applause. As we can see here, it's basically, a core ecosystem package here. So folks are sponsoring it, folks are invested in this, and the community's invested in this. So it's just, I know it's great to see that, Brian. After Log4j and everything, and I think people understand now, the maintainers are the superheroes, right? So I love being able to feature projects in such a positive light.
Yeah, for sure, and, like, to see that quick of a turnaround too, because there's somewhere, depending on how lively and how well maintained a project may be, how much support a project may get, a vulnerability may take I've seen it where it's taken years before that PR like, somebody might have done the work and do a PR, and it doesn't get merged for years
Yeah, we'll,
for it,
we'll
you know what I mean?
definitely talk about an issue like that pretty soon. I think some people here might be able to guess, but yeah,
Yeah.
there are definitely times where there's something, the vulnerability that's announced, and maybe an exploit doesn't exist, and then everybody's just kind of twiddling their thumbs waiting. But yeah, I think it's definitely a model that, and a pattern of behavior that will fall out of favor. I think folks are realizing now, right? Like, as soon as you're aware of security defects, right? Whether you're an open source maintainer, whether you're a company, it's best to just patch them. So if it was fixed, why the POC still works? Great question, Ozek. So the POC, we're actually talking about an older version of the software than the most recent one. So folks might not be able to update their software for whatever reason, right? Maybe you're beholden to a very high standard of log retention. You can't turn off these servers and miss these requests, right? So like that's a reason why people couldn't update log4j immediately. But you can sort of think of it in a similar way. If folks are relying really heavily on this package, which they probably are, right? It's a core ecosystem package. It's, as we outlined, it's used in a lot of very, very popular open source community driven projects. So I think that's basically the reason why this POC still works. We're looking at an older version rather than the most current version. So after so the most recent two like versions I think are it's patched already, something like that. But yeah, from 3.0.0 to 3.1.13, um, I think
Yeah, I'll
that
share my
was.
screen to show that. That very good question and answered perfectly, Ozik. So, um, you could see here very specifically the detailed path. So if you install 3.1.30, that's where the vulnerability is, and you need to make sure you're on 3.1.31,
Mhm.
and that way you'll be able to fix it. And then the other thing I was double checking here is that in the package you could see the proof of concept that links to StackBlitz that maybe you're checking out, Ozik, is intentionally set and hard coded to or pinned to this version, the vulnerable version 3.0. So when it spins up, runs npm install, it goes and intentionally gets the vulnerable version so that the proof of concept can work and still demonstrate how the vulnerability is working there.
Yep, yep. And so if you have, these extensive packaged JSON files are usually a lot larger than this for, most
Mhm.
people's projects. The best way to determine whether you're using a version that is vulnerable is to run it through, right, a SCA system, right? At Sneak, we've open sourced our SCA. A lot of SCA you usually have to pay for, especially if you're going to use it in your command line or, you're going to embed it in your CI/CD system or you're going to use it in your IDE. So we're pretty glad to be able to offer these developer tools, free of charge for folks just to write better open source software and to protect their companies as well. So yeah, if you have that somewhere, check out your package JSON. Check out the version number, update it, run some tests, and then push it to prod. Right, and then
Really
cross your
quick,
fingers.
Kyle, and I know you've explained this before, but you know how I am. I'm always concerned or not concerned or thinking trying to think about from the perspective of people that haven't heard these things before. When you say ska, what are we talking about? Like
Sure.
the music genre?
Right. Let me pull up my trumpet. Um, I think, when most people hear about like security tools, they usually think about like attacking, but like there are a lot of developer oriented security tools. Sneak's really leading as far as like security developer tools, right? That's what I think. That's why I'm here. So I really, like the tools that we use, and I actually use them, while I was working for clients, attacking computers, right? And basically, when we do SCA, it's called software composition analysis, right?
Okay.
And the composition of your software, as we know, there's some code that you write, but then there's code that other people write. And usually the code and the frameworks that we rely on are much more extensive than the implementations that we're writing ourselves. So I think that is, the TLDR is SCA analyzes your open source packages that you're using in your manifests, in all your various manifests, and it gives you, it should give you a very nice developer friendly report so that you can remediate it, or it should create PRs automatically like Sneak does. And then you approve those PRs after your test pass, or however you integrate your seamless SDLC. And this is a great way to basically get on the DevSecOps train and really like lead the transformation. I think from the archaic push now, analyze later, to like let's start failing when we're introducing critical vulnerabilities into our code base. Let's analyze our open source packages, our dependencies, our like our licenses, right? So I think open source management, it's just the name of the game now, and DevSecOps is it's important to just have that the entanglement of DevSecOps in every part of the SDLC. From all the way left at ideation and like the first couple commits to deployment and pre-prod and all those environments. It's important to sort of embed that into the process and make it developer friendly, and so that's not such a pain. As you go further into that process, things get more expensive. So SCA is like the best first place to catch things. It's the cheapest, right?
Nice. Yeah. Thank you for clarifying on that. And I shared that link in chat for folks that might be interested in what you're talking about from Sneak, the open source product that's basically that's what it's called, right? If I'm recalling correctly, you keep me honest, right? Sneak open source is the ska solution by Sneak.
Yep, yep, you got it. And our SCA is, you can do it so many different ways. You can do it through the web UI. You can, go in the web UI and link it up to your GitHub projects, or you can just do it in your terminal. So you can basically start a project that will exist you can create some code just locally. You can run, Sneak Monitor on it, and then you can create a project just by running Sneak Monitor in your CLI in your terminal. I don't like leaving my terminal for web apps, Brian. I'll put that out there. But obviously I do it when I have to, but I'd prefer to stay in the terminal. So for me, the ability to just say Sneak Monitor in my terminal and then have a project up there, in the web UI if I need to share that with somebody, like that's a huge win for me. That saves me time, right? It saves developers time. And developers, we live in the terminal, we live in the IDE, so I think that's really the name of the game as far as saving time goes, is like integrating all the ways you can and making it like really easy for folks.
So you say you don't like leaving the terminal, but I question that in the sense of, is it more you don't like leaving or more you get stuck in the terminal because you can't exit Vim? But got him.
It's great, Brian. You can set up calendar appointments using your terminal.
What?
You can integrate Google Calendar with your, yeah. I used to have my terminal in ASCII like over my like Linux tiling window manager as my background. I had like NASA picture of the day, and then the ASCII would change based on the NASA picture of the day. It
Wow.
would add all the colors, and then I'd have my meetings and like the bar going throughout the day, like an ASCII bar going throughout the day. It was super fun.
All right,
I
we
used
have to have. I got an idea for a show now. It's just terminal tips with Kyle.
Terminal tips. Ooh, we got to do terminal tips. That sounds like a great idea.
Yeah. Boom. There it is. Speaking of shows, I think that's the end of our show, right? What'd you say? Do we have any more
Definitely.
that we need to cover?
I think we're good. I think we hit everything we wanted to. If anyone has any like last questions, those are our Twitter handles right there, and we can totally, you can reach us anyway. But we're both pretty available online. And if you have suggestions for the show, some feedback, definitely feel free to drop it in chat. We will see it. Thank you, everyone. Be sure to follow us on Twitch for more of these. You'll get a notification as soon as we go live. And yeah, just hit that follow button. If you're on YouTube, same thing. Just hit that subscribe button. You'll see us go live. And we're going to commit to at least one of these a month, hopefully more. I think we're going to have a lot of good content for you folks.
Excellent. We'll see you next time. Thanks, everybody. See ya. Bye. I'm just gonna keep doing this. Kyle, leave, man. Don't leave me hanging.
Oh, I did. I did. I didn't know we were still on.
Got him.
Oh, you did get me. Oh my God.